Well, hello, this is Lesson 15, Saxon Course 2. Now, we've been talking quite a bit about fractions recently, and this is a continuation of that. This particular lesson covers quite a bit about equivalent fractions and reducing fractions. So we're going to spend just a little bit of time talking about that and maybe just learning how to draw some models so that we're able to represent fractions in all different ways. First of all, one of the vocabulary words that we need to know is equivalent. Now, fractions can look different but still be equivalent. Different fractions that all name the same number are called equivalent fractions. For instance, this is the same box. Half of it is shaded here, 1/2. 2 of the fourths are shaded here, but guess what? It still covers the same area. 3 of the 6 boxes are shaded here, but still covers 1/2 of the box. And 4 of the 8th are shaded here, and that still covers 1/2 of the box. All of these show 1/2, and they look just a little different, but guess what? They are all equivalent. So that's one of the first major vocabulary that we need to talk about in this particular lesson. Now, as we work with fractions, there is a property that we've already been introduced to that we need to be aware of. It's called the identity property of multiplication. This property actually allows us to multiply any fraction by 1 or its equivalent 1, meaning like 2/2 or 3/3 or 7/7 or 40/40, and the answer will be equivalent. As seen below here, okay, you've got 1/2 times 2/2. Well, we all know that 2/2 is really just 1. So we get 1 times 2, which is 2. 2 times 2 is 4. It still is 1/2. Down here at the bottom, we have 1/2 times the equivalent of 1, 4/4. 4 times 1 is 4. 2 times 4 is 8. Reduce it, and it ends up to be 1/2. They are both equivalent to what they started with, but we just multiplied them by what I call a special 1. Okay? Now, we can use this to find equivalent fractions with the specific denominators that we are asking for. For instance, if I want a denominator of 12, that means that the bottom I want to be 12. What can I multiply 2 by to get 12? Yeah, 6. Well, if I multiply the bottom by 6, I must multiply the top by 6 as well. And I end up with 6/12. And this 6 is really just a 1 because it's 6/6. Same thing with this one. I want a denominator of 12. 6 times what is going to give us 12? Oh, yeah, 2. And what I do to the bottom, I have to do to the top. So 1 times 2 is 2. Now, we're looking for denominators. So this 3/4 can also be turned into a fraction with a denominator of 12. How do we get 12 with 4? Yeah, we multiply it by 3. And what we do to the bottom, we do to the top. Again, this is what I call a well-chosen 1. 3 times 3 is 9. So we've been able to take a fraction and turn it into an equivalent fraction with a denominator that's different. If you were to reduce any of these, you would come out with the original fraction. Now, to reduce a fraction does not mean necessarily that you're going to change its value. You're just writing it in lowest terms. It doesn't change the value. 6/12 and 1/2 still have the same value. Okay? A factor, which is something we already know about, is a whole number that divides another whole number without a remainder. Now I have a good example of that. 6 is a factor of 12 because 12 divided by 6 is 2 with no remainder. Now, the next thing that this particular lesson talks about is writing improper fractions as reduced fractions and as mixed numbers. Example, we have 27/15. we're going to reduce this and write it as a mixed number, both. So if we're just going to reduce it, okay, just flat reduce it without worrying about the mixed number thing to start with, we would actually find something that would go into 27 and 15, which 3 would work for both of them because this is 9, this is 6, both divide by 3. So if I divide the top and the bottom by this well-chosen 1 here, 3 over 3, I get 9 over 5. Now that's an improper fraction, so we know how to change those into a mixed number just simply by doing our division down here. We end up with 1 4/5. Over here, they are asking you, well, we want a mixed number. Well, let's write the mixed number first and then reduce. So that's okay, we can do that. We take 27, divide it by 15, we get 12 as a remainder. So it's 1 12/15, and that's not in simplest form. So we go over here, use our special 1, 12 over 15 divided by 3 over 3, which is basically 1, but it does help us to reduce that. The only thing that's tricky about this is to remember to bring that 1 down here. You got the 4/5 over here and then 1 there. But guess what? Doing it both ways gives us the exact same result. Lastly, I just want to talk about rewriting percents as reduced fractions. And this isn't all that tricky. I know you guys have gone through this before. If you start with 10%, that really means the same as 10 over 100, which is the same thing as 0.10 because that's 10 hundredths. Same as 10 over 100. If you divide top and bottom by 10, you get 1/10.